All right, we are continuing to work on properties of logarithms. This is the second video. So, example 4, changing a base using common logarithms. This one says evaluate log base 3 of 8 using common logarithms. All right, using common logarithms means log base 10. So we can do that using our calculator. And this is one of the standards, is being able to use the change of base formula. So we're just going to type it in as log of 8. I'm going to close out my parentheses and then divided by, remember change of base formula says we're going to do log of 8 divided by log of 3. And that's just using the formula, change of base formula. All right, and it's that simple. So if you evaluate, it's going to be about 1.89. And depending on how they round it, sometimes they round it to the hundredth, sometimes the thousandth. If we round it to the thousandth, it would be 1.893. The 2 would become a 3 because of this 7. So let's put 1.893. All right, I'm going to show you another way to do it just because these calculators are pretty handy. So if we do math and we go up to log base, this is not using the change of base formula. This is typing it in straight like it is. So log base 3 of 8. And it's going to give us the same answer. So you can see that the change of base formula is just another way to do it. These calculators, if you have a newer TI-84 calculator, a TI-84 Plus that's been updated, you can enter the base in just like it is. But on your EOC, it does ask you to use the change of base formula, so please be aware. Gives you the same answer, but just depends on how they ask you to do it. This one says another way. You can also evaluate log base 3 of 8 using a natural logarithm. So remember, the natural logarithm uses base e, and we use ln to designate that that's the natural logarithm using base e. Log, we use that as the common logarithm for base 10, natural logarithm base e. So these are just vocabulary terms that you need to get familiar with. I know logarithms are new, but the more you get familiar with these vocabulary terms, the easier it will be and the more things will make sense. All right, so it shows you here that if you use the natural logarithm, I'm going to show you on the calculator as well. If you use natural logarithm, that's ln. Again, that just means base e. And the change of base formula basically says it's just changing a base to a common base. So if we're using the natural log, and then we're dividing by the natural log, we are still using a common base of e. So again, this is a third way to do it and still get the exact same answer. So this is change of base using common log. This is using your calculator, the log base button, where you can enter the base given, and then this is using natural logs. Example 5 says changing a base using natural logs. So that means we're going to use the ln, which represents natural log, and we know that again means base e. So if we evaluate log base 6 of 24 using natural logs. Getting tongue-tied this morning. Let's see. All right. And again, there's multiple ways that you can do this. I've just showed you 3 different ways you can do it using this calculator. But it's asking us to use the natural logarithm. So we know we're going to do ln. We're going to do ln of 24. So the natural log of 24 divided by the natural log of 6. And that's going to give us 1.774. So this is going to be 1.774. And very quickly, again, if you want to use the log base button, you can type in log base 6 of 24. It's going to give you the same answer if you use your common log. Because again, we're using change of base formula here. So again, 3 different ways. You're going to get the same answer no matter which way you do it. I do try to follow what it says though. So since this one said using natural logs, that's why I did it with using natural logs first. Example 6, modeling real life. For a sound with intensity I in watts per square meter, the loudness L of I of the sound in decimal is given by the function L of I equals 10 log of I divided by I sub 0, where I sub 0 is the intensity of a barely audible sound, about 10 to the negative 12 watt per square meter. An artist in a recording studio turns up the volume of a track so that the intensity of the sound doubles. By how many decimals does the loudness increase? All right, so intensity is I, loudness is L of I, and then they give us this function here, and I sub 0 is the intensity of a barely audible sound. All right, so an artist in a recording studio turns up the volume of a track so that the intensity of the sound doubles. So we need it to double. By how many decimals does the loudness increase? All right, so let's start by saying let I be the original intensity, because it shows right here that I is the original intensity. So we know that 2I is going to be what it is when it doubles. So if I equals intensity, we know that 2I is when it is doubled. All right, so we want to know the increase in loudness. So what does that mean? So how much is it going to increase in loudness? So we know that the function is written by L of I. So if it's going to be L of 2I, that's the intensity when it's doubled, or the loudness when it's doubled intensity. And then we're going to subtract the loudness of the original intensity. And that should give us what we're looking for, because what we're trying to figure out is by how many decimals did the loudness increase. All right, so with that, we are given this equation here. So we know the loudness of intensity equals 10 log of I over I sub 0. So if we substitute that in for 2I, the only difference is 2I is going to be in place of the intensity here. So for the first one, we're going to have this is going to equal 10 log 2I over I sub 0. All right, and again, that comes from right here. The only difference is this is when the sound is doubled, so that's why we have a 2 here. And then we're going to have minus the loudness of intensity is 10 times log of I over I sub 0. And that is exactly this, because that is given for both intensity and loudness. All right, if we look at these here, we can see that they both have a 10 in common. So first thing we're going to do, let's factor out this 10. So let's bring out the 10. If we bring out the 10, that leaves us log of 2I over I sub 0 minus, again, we pulled out the 10, so it leaves us log base I over I sub 0. All right, so if we use our properties of logarithms, we have a product right here. So that means we're going to have to rewrite this first part. Remember, a product turns into addition. So bring down the 10. We're not doing anything with it yet, but we can rewrite using logarithmic properties, log2, and then a product, remember, becomes addition. So plus log I over I sub 0, and then minus log I over I sub 0. Now, why did I do that? That separates this part. And now we can see that log of I over I sub 0 and log of I over I sub 0. So if we have a positive and a negative, this actually cancels out. So that leaves us with 10 log of 2. And then we can evaluate what 10 log of 2 is. So if we pull up our calculator, all right, so if we type in 10 log of 2, 3.01. So how many decimals did the loudness increase? We're going to say about 3. So this is going to be about 3 decimals. All right. And that is all 4 properties of logarithms. If you have any questions, please let me know.